Hello students, welcome to this module number 3, the chapter the second of thermodynamics. Here we have to discuss about equivalence of Kelvin-Planck statement and Clausius statement, and along with the concepts of PMM1 and PMM2. Okay. So already you know that the what is the Kelvin-Planck statement and Clausius statement. Okay. So for this concept, so we have to uh, prove that both statements are mutually same. Okay, how it is we will discuss now. Okay, let us consider this figure. So in this figure you can see that is the left side, that is the heat pump will be there. It will be operates in a cyclic manner and transfer Q2 amount of heat from a low temperature source without any work input. Okay, so it is not taking any work input, and this system violates the Clausius statement. Already you know that means some external energy is required to from transferring the lower temperature region to a higher region. We need some energy input, external energy input, but we are not considered, so hence it is violates the Clausius statement. In other side, consider figure B. What happened? The heat engine will be there. So in this heat engine, it is also operates in cyclic manner, and it's absorbing a human amount of energy, and it is performing from high temperature, and it performing some work. This engine does some W amount of work, and it finally rejects the heat at a Q2 amount of heat to the low temperature sink. Okay, this system operates as per the Kelvin-Planck statement. So at the first figure it is violates the Clausius statement, and second one is it is perfectly follows the Kelvin-Planck statement. Now consider third one, this figure. In this case, what happened? Both heat pump and heat engines are combined and to form a combined system, and this system constitutes a device that receives the Q1 minus Q2 amount of heat. Okay, so whatever the Q1 minus Q2 amount of heat will be there from the higher temperature source, and it does the equivalent amount of work, that is W is equal to Q1 minus Q2. So what we can conclude that this system violates the Kelvin-Planck statement, because here it is not rejecting any heat. By combining that Q1 and minus Q2 amount of heat only is performing the work, and it doesn't any rejection of it. So it violates the Kelvin-Planck statement. Okay, so thus what we can say, the violation of Clausius statement leads to the violation of the Kelvin-Planck statement. Okay, so we'll come to the Clausius statement. What it says? Okay, so in this figure, again we can see we consider high temperature source and sink. Okay, um, here that is consider the figure. Okay, in this figure what we can say, the first figure in this case, the heat engine extract the Q1 amount of heat from high temperature source and does an equivalent amount of work, that is W is equal to Q1, without rejecting heat to the low temperature sink. This system violates Kelvin-Planck statement. Okay, and coming to the next figure, that is B. So in case what happened in this case, the heat pump working in a cyclic and extract the Q1 amount of heat from a low temperature sink. This heat pump also receives a W is equal to Q1 amount of work from external source and supplies Q1 plus Q2 amount, that is the heat temperature source. Okay, this system works as per the Clausius statement, because it works on the Clausius statement, and it needs some external energy that it is working. Okay, so the figure 3, what happened? That is figure C. The both heat engine and heat pump are clubbed together and to form combined system. And since the output of the engine W is used to drive the heat pump, and input of combined system is only from the Q2 amount of heat extracted from the low temperature sink. The system rejects the same amount of heat to the high temperature source without any external work. The system is violates the Clausius statement. See, already you know that for the heat pump we need again some external agency or energy to uh, lift the, or it will be to from a low temperature to high temperature we required some energy source, but here it is not taking any external input, so it violates the Clausius statement. So the violation of Kelvin Planck statement leads to the violation of the Clausius statements. Okay, so what we have to do is, first we have to explain about the Clausius statement leads to the Kelvin Planck statements violation of Kelvin Planck statement. In the next way, so we have to explain the violation of Kelvin Planck statement leads to the violation of Clausius statement. In this manner, we have to explain. So, what happened finally? What we can conclude? So we can conclude that the both Kelvin Planck's and Clausius statements are equivalent in sense. So both are uh, same. Okay, so from this one we can conclude the equivalence of Kelvin Planck statement and Clausius statement. Please go through this concept, and it is very important. Once if you understood the concept of second law of thermodynamics, we have to combinedly we have to take these two statement and we have to prove as both are in a same sense. Like that we have to explain. Okay, so I hope you understood this concept, and the further topic next one is the perpetual motion machine of a second kind. So very simple. In the perpetual motion of first kind is the violation of first law of thermodynamics. Okay, the violation of first law of thermodynamics. But whereas preparation of perpetual motion of second kind, it is an engine working on cyclic developing network by exchanging the heat from single source. That is a PM2 violation of uh, Kelvin Planck statement. So PMM2 is a violation of second of thermodynamics, whereas PMM1 is violation of first of thermodynamics. So here what he is saying that it is not possible in an engine from a single thermal reservoir to complete work is converted into or heat is converted into work. So it is not possible. It is required minimum two thermal reservoir. So that is what is from the statement. That is PMM2, perpetual motion of second kind. So I hope the everything concept you understood, and we move on to the next slide next in the next video. Thank you.